Good afternoon, everyone, and thank you for joining today's webinar. My name is Joanne from Rockford Dynamics Europe team. Today, we welcome our last guest speaker of this series, Hemant Gurav, Petroleum Engineer at Cairn Energy in Edinburgh. Hemant is going to present to you a day in the life of a non-operated reservoir engineer, and will describe some of the workflows that Cairn Energy have used within tNavigator to overcome the challenges of a brownfield analysis, including history match and forecast. If you would like to see any of the other webinars in this series, please find them on our YouTube channel and do let us know your feedback. If you haven't joined one of our webinars before, all microphones have been automatically muted, so if you have any questions, please type them into the window on the control panel to be answered at the end of the session. Hemant will be happy to answer your questions, and I also have my colleague Alexandra from our technical team here to answer any tNavigator related queries. We usually receive quite a lot of questions, so if we don't manage to answer yours during the webinar, we will follow up with you in the coming days. We also have permission to record this webinar, and that will be uploaded to our YouTube channel in due course. And if you'd like any other information, don't hesitate to reach out to us on asktnav@rfdyn.com. So now I would like to hand over the controls and say a big thank you to Hemant and Cairn Energy for participating in this webinar.
Hi, Joanne. Thank you for that introduction, and hi all. So just a quick introduction. Basically, I've been working with Cairn Energy as a petroleum engineer for the past 10 years now, and have been working primarily on exploration and appraisal for most of that duration. The bulk of it was Senegal, which you might have heard recently in the news. At the start of this year, I was assigned the responsibility for our production assets, which comprise of 2 UK North Sea fields, which are Kraken and Catcher, both of which are non-operated. So it was a big shift from what my role and responsibility was as exploration and appraisal petroleum engineer to a non-operated reservoir engineer. And I've just put a short summary there of what it entails. And it's, well, not restricted to these items, I may add. So anything and everything from, well, primarily generating production profiles, which are used to drive the business plans of our company. And this is reserves reporting forms the bulk of my responsibility. There's also reserves audits conducted by third-party personnel, by competent persons, and I have to justify my profiles to them and our reserves position of the company. Use those reserves for reserves-based lending from the banks, which forms an important part for our capital and for our future projects that we can invest in. Also, there's usually firefighting or day-to-day things that need to be evaluated, such as production of facility upsets and see the impact of that on the profile. Along with that, there's daily, monthly, and quarterly reporting, and it's quite a task if you have to do this all side by side. So it's a limited time window for assessment, basically. I usually get models or updates from the operator a month or so before our company's internal deadline. So there's quite a short time frame to turn things around. And if you don't have tools or a plan in place to tackle these, I would say be prepared to say goodbye to your sleep. So basically, this is the plan I follow. And it's a simplified workflow that I will take you through the presentation. And it's mainly split into three parts here. First is just to assess the models that you get, compare and contrast using the graphical interface that you have within your company. Then, based on the the ranges or the analysis that you've made. And if you want to test a few things, you do that using the assisted history matching workflow. And then once you're satisfied with your best matched model, take it into forecast mode. Things to note here, though, you need to understand how much work this entails. Usually, you need to know what the model runtimes are. When will you have the final forecast ready? What is the submission deadline for the commercial people to run the NPV and IRR numbers? And can it be delivered within the time frame? So you have to have a good idea of what your high-hitting parameters are in terms of uncertainty and how they can impact your profile and the history match. So to begin with, and to make sense of it all, you just have to sort of take a step back and recognize where the project is in terms of its current life cycle. And it's essential, I would say, to have an understanding of the parameters that are most uncertain in the field. And these could be static or could be dynamic. If you're new to the asset, the FDP is the best place to start. I would say you have to understand that the operator position might be different to the position that your company takes in terms of uncertainty ranges, and especially in terms of, okay, is the operator being optimistic with certain assumptions? Are they being too pessimistic? What is their philosophy in terms of the ranges that they carry? Also, are they, if they are realistic, then is it okay to be realistic, or do we need to be optimistic, or is there further room for improvement within the asset? These are the sort of questions that one has to ask, and decisions that one has to take based on the answers that you get from these questions. And basically, I mean, like Joanne mentioned, we both of these assets, the Catch and Kraken field, you would say the greenfield, but I mean, based on the water cut development and the stage where they are at, whereby we have 3 to 4 years of production now, we are at the point of calling them brownfields, whereby the range of uncertainty has narrowed a bit now. The in-place volumes don't change much. There's not a lot of degree of change in terms of what's there, and so your range of uncertainty of in-place volumes is lower, and as a result, you're looking at reducing that range of uncertainty going forward. So this is basically your beginning point to take things forward. Also, you have to understand what kind of optimization there is, or there can be done, and use that to make decisions based on what kind of profiles you want to generate. So what do I do basically? So I'd like to have your attention here, just to start off with. As soon as I get the models from the operator, I run them quickly to see if all the files are in place and the results can be replicated. Now, it's all obviously useful if you have the same software as the operator, as it cuts out the time that you have to spend in moving between different platforms and worrying about consistency and repeatability of the models. Luckily, for both of the operators, for Catch and Kraken, they both use tNavigator, and we had a license as well. So this eliminated the added time required for this due diligence that needs to be performed. Some operators are kind enough to provide you models in different formats, so you don't have to do that, but some don't. So it's good to ensure that you understand where you stand to begin with. The next step is basically to compare and contrast, and the graphical user interface that that tNav had was quite useful for me in terms of the models that we hold. So ideally, you will have, well, I don't know if people have multiple models, but in terms of Cairn, it is, sorry, it is 3 models, low, mid, and high, for the respective assets. And based on what you had previously, you will want to compare and contrast with what you have now, or with the latest update that the operator generates. And the GUI is great for that, because you can just load in models and have everything in one place, and just quickly look at things. And I suppose, I mean, preaching to the choir here, but I suppose you look at your cumulative production, which gives you a good idea of your quality of match to begin with. I take a look at if you're lower or higher there, and check the quality on why that's happened. And in terms of the fields that we have, they are water flooded and have underlying aquifer. So it's best to check the quality of the water cut trend, because that sort of gives you a good indicator of how things are to begin with. And the field level is a good start to begin with. But a word of caution: there's a lot of behavior that is masked at this level. You usually have to drop down a few levels just to understand what's happening and why you're seeing the things you're seeing on your water cut trends, basically. So the group level is the next step down. Again, different companies use grouping differently. You have to see, first of all, whether the grouping is appropriate or not. Are the wells in the particular group governed by the same displacement mechanism or not? And if not, why not? And try to understand why, or if you can group them differently, and whether it's appropriate to do so or not. And then basically you go down to your well level, and eventually see what's happening, and basically look at your problem channels. The pressure matches there are a good indication of whether volume has been captured correctly or not. So, I mean, it's quite easy in tNavigator to do this, and I found that definitely for me it was good to cycle through different groups or different wells quite easily, based on the options that the software provides you with. And the other useful thing was you could just set up your own templates, basically, and have graphs side by side, so that you can compare everything at once in the same panel, and not moving between different windows, so as to say, or copy pasting data into Excel just to make sure that things are looking the same. So it was quite a good time-saving exercise that that tNav sort of helped with, just so everything was in one place. All things can be compared and contrasted quite easily, and you get down to understanding what things have changed, and ask the right questions on what has the operator actually changed. So this was mostly with regards to your history match, but then you will have received your forecasts as well alongside that from the operator, and comparing those forecasts, your production profiles of oil, water, and gas with what you had previously, it's quite a good visual to start off with. You look at your shape of the profile and the decline, see if there are major differences there, and then well, based on those two things, you can just clearly tell what's changing quickly in terms of your well, have they changed the well limits? Have they changed the facility limits? Why is it that you have more gas, or why is it you have less gas, or why do you have acceleration in some profiles? These are all good things to sort of quickly narrow down upon, so you can sort of quickly understand and get to grips with the asset to begin with. The wordage replacement ratio is quite key as well. You just have to quickly look and see if the model is not over-injecting and we are having an optimistic profile or not, or under-injecting and we are having a pessimistic scenario in that case. So it's good to have a quick check, and usually most of the softwares I had previously wouldn't have the wordage replacement ratio. It was quite neat that tNav provided that within the software itself. So it was, saved me time from moving data between different platforms in effect. So yeah, armed with all these, all this analysis and identifying the parameters that have changed and questioning the underlying assumptions made by the operator, I then sort of decide, okay, what's most important to me? What is our company position? How am I supposed to, or how and what do I need to address in order to justify that position? And so, well, this is just a slide here, but just to show you some of the tools that I used when I did the analysis. A few of those results tables that tNav provides are quite useful in terms of the R square fit. It's quite a good visualization of your good and bad matches, and lets you know pretty quickly how much or what degree of variance is there within the model. Stack plots are one of the things that I used because they quickly help you identify the wells that need attention or are significantly off from your history match. So armed with the information, like I said, I then move on to the assisted history matching mode, whereby I decide that I want to test a few key parameters, which I believe have a wider range or narrower range than what the operator is carrying. And this was quite neat and efficient. And in tNavigator, I thought the assisted history matching module was quite neatly arranged. You can see all the variable ranges and inputs. Well, first off, you can basically drop down one by one and then address every uncertainty that you hold within the field. For me, for a particular field, it was some of it was testing the contacts that were there in the field and the relative probability ranges for my case especially. We had a report that had just been issued in terms of a review that was conducted for the relative probability, so the information was different. The operator, though, hadn't modified their ranges, so I needed to test whether or not the new ranges made any difference or what impact it had on my my history match quality. So I took that into this software. There was well, I guess the workflow is quite straightforward, and there was There's quite a few guides online, as you know, from tNavigator that helps you to go through these things pretty quickly. Yes, there were a few issues when I tried setting it up early in May, but I usually found that the guys here were quite good at getting back with your requests and taking you through things if you were stuck, which just helps save you a tremendous amount of time rather than sort of moving about or jumping from one thing to another and not getting to doing the analysis itself. So what I did was, well, use a Latin hypercube method because you can specify the number of variants there, and this was a good suggestion from their help desk because you can sort of minimize the amount of runs that are required basically, and still get a good quality of history match so that you save time. One of the models I had, the runtime was a couple of hours. If you're looking at a history matching project and are thinking of running 50 cases or so, that's 100 hours. So that's 4 days or something, basically. So you have to make these decisions based on the time you have. Obviously, when I went through the process, I did get a best fit quite early on within 25 runs, so that was quite fortunate. But if you are short on time, you have to sort of understand which is the right method that you want to use for this process. And so again, yeah, there was the custom objective function such as your oil rate mismatch or your oil total mismatch that you could choose to select your best model variant for a set of parameters. And yeah, just once you have those results, well, it's quite nice and tidy in terms of how things are laid out in the software itself. All the variants that are generated automatically, they are all sort of on the left hand. The best matched ones you can select and then rank them highly here and bring them up to the top. You have different plots here again, your Pareto charts, which shows your positive and negative correlations for different parameters. I've not put the actual data here because I didn't get the necessary permissions here, but it's just the plots sort of highlight things that are quite neat and handy, and it's all within these tabs here for histogram, which is quite good. Another thing is the bands of variance that you can put across your actual data and see which models fit within that band. Quite good to quickly narrow down upon the runs. There's also a difference plot here, and it helps you to select your best match models. And basically, well, the last one was the stack plot, which sort of helps you identify your wells that need attention. And obviously, you can't have a perfect model because the nature of the beast is such that there's always going to be issues with your model because it is a model after all. Some of the wells which you can't, whose behaviors you can't capture correctly within the model, these will be scrutinized by the auditors, and you have to sort of understand what the challenges are there and how you need to justify the reserves that you're predicting from these models to the auditors. And that's basically what I would say is you have to have your story ready, and this will be quite these tools here sort of help you sort of understand things and then decide what what to highlight and decide what to use to justify your position. So once you have your best match models, then I'm sort of basically looking at my forecast and my forecast assumptions. I decide on the well limits for the producers and the injectors. Obviously, the operator has sent me a model with their well limits implemented, and these can be driven by the existing plant conditions, or they could be based on assumptions. And what I look at is basically if it is, what is it based on? Are the assumptions, if it's on assumptions, what are those assumptions based on? Are they based on the current reservoir management strategy? Are they appropriate? For example, if your bottom hole pressure is above or below bubble point, and that's your management strategy, so as not to con gas from the reservoir or out of solution, and that is something that you might have to adhere to within your models. Injection pressures, where are they set at? Are they set at fracture pressure or below fracture pressure? Is there a safety factor incorporated there to maintain top seal and completion integrity? That's one of your concerns as well. Also, where is the room to optimize? Pump rates and design limits are the main things that I look at to see what the current operation conditions are and how much room there is to actually move and change. And if you are deciding to defer on these assumptions, well, you need to make sure that whether you're being optimistic or you're being pessimistic or you're being realistic again, and where does the operator sit, for instance. And this is, it was quite a good thing, the transition from history matching to forecast again in tNavigator. There's quite a good few options there. There's a no further action scenario whereby you just let your wells go at your current operating conditions, so you don't have to generate, or there's an automatic generation of the schedule deck based on that, which is quite handy. But well, there's the other way, which is a custom schedule, whereby you go into the deck itself and copy paste your schedule file as you seem appropriate. I'm more from the old school, so I prefer doing that. There was the other option of optimization, whereby I could put some variables within the schedule deck itself and then change them here, but I didn't pursue that. But that may be for further iteration. And then at the end of this, again, you have your forecasts. You are in a good place. You again compare and contrast them with the operator, see whether they are appropriate or not, and then you decide which profiles to be used for the asset going forward. So that was basically it from my side. That was 2 to 4 weeks of work summarized for you guys in 10-20 minutes right now. So what are the conclusions that I had? Basically, I found that the tNavigator graphical user interface was a useful tool for quick evaluation, and the primary goal of mine was to save the amount of time, and the assisted history matching module was really good for my purpose, because of its easy to use interface and the workflow setup that you have there. Also, I would add the help desk and the support desk was really good. I wouldn't have met my deadline for delivery otherwise if it wasn't for the help desk from tNavigator. And obviously the runtimes, the parallel processing ability is quite handy, and it saves tremendous amount of time. I started my project working on a workstation, and then in the midst of it, we went to cloud, and it just the runtimes just went up. I don't have the details to hand on the cores and how much we changed, but obviously there's a shift there, and helps you save time again. So yeah, that was basically it from me. Thank you for your time, and I'll be happy to take any questions now.
Thank you very much, Hemant, for the presentation today. We've sent a few questions over to you, so we'll just give you a little minute to read through some of those before we go on to questions. In the meantime, as I said earlier, this is our last webinar in the current series, so we just want to say thank you to everyone who has joined the sessions, and extra special thank you to our guest speakers. So Hemant from Cairn, we had Vermilion, Neptune and OPC as well over the last few weeks. So hopefully it's been interesting for the audience to hear how tNavigator is being used. We'll be in touch soon with more details about next events, but in the meantime just keep an eye on our LinkedIn page for all the latest tNavigator updates and NFT news. Shall we go into some questions?
Yeah, I mean, I'm happy to take on a few. I've got a few from Peter Colleran, if I'm pronouncing that name right. And the first one of his questions is, are some operators more cooperative than others, and how do you, inverted commas, seduce them into cooperating? So that's a good question, I would think. It's just, I suppose, they're obviously the working styles and philosophies are different between different operators in the North Sea. I have definitely found that some are more cooperative than others in terms of how you actually seduce them or help them or ask them to cooperate better. I guess that's the challenge you face as the asset engineer. You have to be on the pulse, and you have to ask relevant questions and challenge them from time to time. You have to address issues via, well, first of all, get an understanding of what it is that you want to target. Is it well optimization, or is it the quality of your history match, or is it the models that you're after? You need to sort of highlight it within meetings, your technical committee meetings, and make sure that you have a positive engagement with them in that forum, and then follow that up with good feedback and questions via email, and obviously make sure that you receive the correct feedback from them alongside that. I don't know if that answered your question or not, Peter, but that's how, or that is basically my approach to these things. And there's another question by yourself as well, saying, is it normal to get fully history match models with accompanying reports, or do you typically carry out your own history match? So what I do get is a fully history match model from the operator. Now, within our company, there are two reporting cycles. One's usually at mid-year, and the other is at year-end. For the mid-year, it's difficult to get a fully history match model from the operator based on, or some operators provide it, some don't. At least one does for us, the other doesn't. So you are left with having to do the history match yourself for the one that you don't possess the model for, and then use that information for yourself. And then what is any other questions? Yeah, so Maria has asked approximately how much time did I save completing my history match using tNavigator and its features tools. So I would say previously the model runtimes were quite long and moving between platforms from tNavigator to Petrolari, for instance, that would involve quite a lot of time for me, and that would probably take. Well, I to answer in short, it shaved off to 2 weeks at least. I would say in terms of analysis. So it was quite useful there. And Peter's asked, has simulation become easier or faster over the 10 years of my career? I don't know. Well, it has become, well, I suppose it has become faster given the processing capability that we have. I suppose along with that has come the responsibility of running more profiles and more runs. So it's not become, the whole exercise hasn't become easier or faster over the 10 years. It's become longer and harder, but you have to understand or have a plan and process in place in order to tackle that, so it becomes easy and faster. And that's my message to you, I suppose. And obviously have the right tools in place to do that.
Cool. Okay. Thank you very much, Hemant. That's us pretty much out of time. There are a few questions that have still come through, but as I said earlier, we will get those answered and get out to you if your question hasn't been answered. So thank you very much again to Cairn Energy for this presentation, and thank you to everyone who joined us. We look forward to seeing you again soon. Thank you.
Okay, thanks all.